Dear friends and my dear students, today I am going to explain you about refraction. We should always keep in mind that reflection and refraction, these are two terms. Both are different. Reflection does not mean two media, that is two mediums, but refraction needs two media, that is two mediums. So, when we talk about refraction, we should always keep in mind that why does it take place? The reason behind refraction is change of speed, change of direction. Then why does the change of speed take place? This is because there is change in the speed of light. We know that the speed of light is 3 into 10 to the power 8 meter per second, which is highest in air. Air is a rarer medium. That means it is optically rare, whereas water is optically denser than air. Glass is optically denser than water. Here we should not confuse with optically denser and mass density. Both are two things. Optically denser we refer only in the case of optics. But when we talk about mass density, that is another thing. So, here now we should keep in mind that in the case of rarer medium, speed of light is highest, and in the case of denser medium, speed of light is less. So, we should keep in mind more the optical density. That means the more the optical denser the medium is, the less speed it has. That means less speed of this light. And if the medium is rarer, the speed of light is higher. Okay. Then we should keep in mind that this refraction, when from rarer to denser medium it travels, there is bending of light. There is change in the speed of light which causes refraction. So, on the glass prism, there is a point of incidence, and at that point of incidence, normal is drawn, and that normal is the perpendicular. And at that point, the angle of incidence is always greater if the ray is passing from rarer medium to denser medium, and the angle of refraction is smaller. They are never equal. As in the case of reflection, angle of incidence is equal to the angle of reflection. But in the case of refraction, it is not so. They are not equal. Now, there comes principle of reversibility of light. What is this principle of reversibility of light? In this case, we find that refractive index comes into play. And then what is the refractive index? From rarer to denser medium, that is from air to glass, when ray passes. Then we write A mu z. A mu z, what does this mean? Refractive index of glass with respect to air. And that is equals to sine I by sine R, which is a constant, that is mu, which is refractive index. Here the first medium is rare medium, that is air, and the second medium is glass, which is denser. So the refractive index of glass we will get, that is of second medium, we will get the refractive index. In the same way, if glass to air there is refraction, then we write G mu A. In that case, also we find sine I by sine R is a constant, that is mu, which is refractive index. And if these two are multiplied, that means A mu Z into G mu A, that is equals to 1. So this is the principle of reversibility of light. And this refractive index, which is mu equals to sine I by sine R, that means sine of the incident angle to the sine of refracted angle is always a constant, which is known as refractive index, and it gives us the law of Snell, that is known as Snell's law. So from Snell's law, we find that mu equals to sine I by sine R, which is always a constant. Thank you. If you like, please subscribe the video.